there's something called the empirical rule. And the empirical rule only works if you know your variable is normally distributed. So if you don't have evidence that your set of data is normally distributed, don't try to use the empirical rule, okay? But it says that you got z equals 0, or in other words, you got the mean right here in the center of your data set. And so if you go one standard deviation below or one standard deviation above the mean, which means if you take the mean and you subtract it by one standard deviation, whatever you calculate that to be for your data set, or if you add one standard deviation, you should have 68% of your numbers between those two. It's never going to be perfect with real world data, but should be close to 68%. Okay, and if you go two standard deviations away, which means if you take the mean and subtract two standard deviations away, you should have 95% of your data. So that's why the empirical rule is sometimes called the 68, 95, 99.7 rule. Because of your three standard deviations away, you got 99.7% of all your people of your data set, or all the numbers of your data set. So where do most of the values of a normally distributed variable lie? They lie near the mean, right? 68% of them are within one standard deviation of the mean. 95% of the data set lies within two standard deviations away. So most, it could be either one of these, but I think when they mean by most, don't they mean more than half? Because look, 95% of the data is within two standard deviations of the mean, so that's true too. So let me check and see what they like for an answer in this one. They want within two standard deviations of the mean. So they don't clearly define what most means. So this is the answer choice they actually want, not this one. 68% of your data, over half your data is within one standard deviation mean. So I don't see a problem with that answer down there, but this is the answer they want.